This is JEE 2025 question. It is based on first law of thermodynamics. Here we have a piston cylinder device which is thermally isolated, and we have to find the pressure at the equilibrium condition. This is connected to a spring. This piston which is separating the two compartments is connected with a spring, and the instant when we are talking when the spring is at the when the piston is at the mid position, its length is L by 2, and initial length was, that is the natural length of spring, is 2 by 5L. So of course there is elongation in its spring, and therefore the force exerted by spring will be towards left. Now considering the ABD of the piston, we have a force from left side, that is pressure into area, pressure in the left compartment into area, and on the right side we have pressure on the right side into area, and plus the spring force. Take this as the magnitude, in fact, K, this change in length into spring index, that is, sorry, this is not A. So K into modulus of change in length, that is final length minus natural length, will be the force exerted by the spring towards left, because the spring is elongated. So once we have the equilibrium condition, so PL into A equals to PR into A plus K into X minus X naught. So the pressure on the left compartment is pressure on the right plus K by A into X minus X naught. Now using the ideal gas equation, we have under pressure in the left compartment into volume of the left compartment equals to number of mole into R into T. From this, if we the volume of left side is A into X, we have assumed that the position is X, like this. The total length is L, and the position on the left side is X. So this length is X. So volume is cross-sectional area into X. So pressure on the left side is number of moles on the left side into R into T divided by AX. Similarly, pressure into right side, this total length is L, so volume of left side will be A into L minus X. So pressure on the right side is a number of moles into R into T divided by A into L minus X. So when we substitute this left pressure and right pressure on previous equation, where the previous equation was relating pressure and the spring index, so this is the pressure on the left side, and this is the pressure on the right side, plus the spring force divided by A. This is the magnitude, this is the change in length. So after simplifying or solving or removing A, we get this this equation, multiplying both sides by A. So when we are solving it, we get the expression of K. You can pause the video and see the algebraic expression, whatever has been done. So K equals to this much. Now here again we have a temperature T, which is the equilibrium temperature. So to relate equilibrium temperature with pressure, we know that pressure on the right side is NR into T divided by A into L minus X, that is on the right side. So we can write T as P into A L minus X divided by NR into R. So when we substitute this in our expression of T, we get this K equals to this much. So the final expression in terms of the spring elongation and final equilibrium pressure and the number of moles is like this. So now we have to substitute whatever is given in the equation. So total length L is given, equilibrium position is that is X is L by 2, X naught is 2L by 5, number of moles in left compartment is 3 by 2, and number of moles in right side is 1. So when we substitute these value, we get x minus x naught as L by 10, and n L minus x upon nRx equals to half. And so when we substitute these values, we get k equals to 5 pa by L, or we can write, in fact the question has asked something p, so p equals to k into L divided by a into 1 by 5. So this 1 by 5, this was the expression which was asked. So 1 by 5 is 0.2. This was written in terms of alpha. So alpha is 0.2. So this is our final answer. Thank you.